This is Jeff. He's your facilities manager. He is a duty holder and responsible for electrical safety on your site, although he himself is not an electrical engineer. John is an electrician working in your business. He is supervised and managed by Jeff. Jeff instructs John to carry out a risk assessment and then repair a fault that has been reported on switchgear powering operations on your site. On this basis, Jeff assumes he has discharged his responsibilities and John is qualified to work on the fault. John makes the equipment dead, opens a panel, tests for dead and begins work on the switchgear. While changing a burnt-out isolator, he drops a spanner. The spanner is about to make an electrical contact between two live-phase conductors that were left exposed when their shrouding was not replaced during previous work. Now let's take a closer look at the electrical installation. The last time the switchgear was worked on, a contractor forgot to replace a shrouding. The spanner will make contact between two conductors. The resulting short circuit will generate sufficient heat to vaporize surrounding metal parts, which will rapidly expand, creating an explosive pressure wave, sending a conducting plasma fireball with temperatures in excess of 20,000 degrees centigrade, or 4 times the surface temperature of the sun, directly into John's path. John will not be protected from the strength of the blast and will receive horrific external and internal burns. 3 days later, John will die in hospital as a result of his injuries. This tragedy resulted from a failure to prevent the incident and to protect John from it, all stemming from a failure to properly assess the risk. Jeff and your company will be personally and legally responsible for this. Dangers like these arising from electrical faults are made more dangerous by their benign outward appearance, with nothing visually obvious to warn of danger. Hazards are often exacerbated when a dangerous disconnect develops. Assumptions are made by duty holders and managers about how electrical equipment is used and the competency of those using it. These assumptions can often be quite different from the reality on the shop floor. Arc flash is a low-frequency, high-consequence event. As such, its rare occurrence can foster a complacency that is utterly disproportionate to the very real consequences that follow when it does happen. In this case, the loss of John's life. Now, let's rewind and see what should have happened. Our process is defined by the 4P model for arc flash hazard management. Firstly, predict. After making an initial assessment, we calculate the severity of the thermal effect of an arc flash on a given piece of equipment, in line with the IEEE 1584 standard for performing arc flash hazard calculations. In the case of the switchgear John is working on, the assessment takes into account distance to worker, voltage, prospective fault current, and disconnection time. Computer modeling of these factors results in a value for incident energy of a potential arc flash. This value is a key component in assessing risk and devising measures to be taken to prevent. Mitigating steps can be taken to prevent an incident from occurring by designing it out, eliminating it, or removing a hazard at its source. With arc flash, completely eliminating the risk is very difficult. In practice, this means trying to reduce the incident energy that would be released by an arc flash, or by keeping personnel at a safe distance from the equipment. The reality is that often arc flash risk cannot be completely eliminated, and so the last line of defense is to protect with PPE, or personal protective equipment, that is suitable for the level of risk involved as calculated in the previous steps. The fourth stage that completes the cycle is publish. All risk assessments must be recorded and may also require field marking and safety signage. Safe systems of work, safety rules and procedures should be devised and documented, with training delivered to anyone affected. Risk assessments need to document the severity of the hazards and measures that have been taken to mitigate against them. Wherever possible, these should be dynamic and task-based, available to those carrying out work, and including the facility for those people to continually reassess the risk based on environmental conditions and the state of the equipment. Now let's return to the arc flash incident. As before, human error has meant that despite John believing the equipment is dead and taking the precautions specified in his training, the exposed fuse switch has made contact with the dropped spanner, resulting in an arc flash. Now, however, the incident energy of the flash is below 8 calories per square centimetre, thanks to remedial work carried out on the equipment as a result of the risk assessment. Furthermore, John is wearing suitable protective clothing, gloves, helmet and visor. The arc flash occurs, but at a reduced energy, and because John is wearing PPE appropriate to the hazard, he is shaken but physically unharmed. This represents a success for the proper health and safety systems and processes.